Hey everybody, welcome back. I'm Bud Churchward, WB7FHC, and I'd like to share with you a recording of a meeting that we had just last night, which was October 20th to 2020, um, with our digital group of our Mount Baker Amateur Radio Club. At this meeting, one of our members, Keith Williamson, KF7DRV, was showing us how he was able to track and predict the path of a Pico balloon that has already traveled once all the way around the world and is now still continuing along. Before we dive into the presentation, let me just bring you up to speed on what a Pico balloon is. You can see one here in this photo. This one. It's like a 3-foot diameter party balloon that is attached to a small amateur radio transmitter. And you can see that the transmitter here has 2 tiny solar panels attached to it. The whole thing weighs about 11 or 12 grams, and these things go quite high. The balloon that we've been tracking was launched 11 days ago in eastern Washington by a school teacher named Trevor McDuff and his high school students. The balloon quickly climbed to an elevation of 40,000 feet, hitchhiked a ride on the jet stream, and in that short time has already traveled once around the world. At the time of this recording, it's still going. The balloon these students launched is larger than the party balloons you saw in the earlier picture, and it's a bit more expensive and much more durable. It's capable of reaching higher heights than the party balloon as well, which is why it's able to catch the jet stream and move along at speeds over 100 miles an hour. Let's check in now with the meeting and listen to the discussion as Keith explains to us how he's able to predict the path that the balloon is going to take and tell us more about the project. Can you tell us about the tools that you were using to come up with these predictions, which were darn on the spot?
Yeah, sure. And I was really fascinated by Trevor McDuff's presentation at the last general meeting, and it just kind of, I thought, wow, this is really neat stuff. And I love the fact that he was using a mid-altitude balloon, because it just seemed like 40,000 feet is above the weather. So you don't have rain and ice, and you don't have solar power issues so much, because it's pretty much bright blue skies once you get to 40,000 feet, obviously when the sun's up. And in his materials, he, and I don't know if it was in the presentation that he actually talked about so much, or if it was in the detailed presentation I looked at, he had this link to this NOAA high split. It's called trajectory modeling software, and just runs as from your web browser. And when I did like you, when the balloon surfaced off of the west coast of Ireland, I thought that was pretty cool. And then I was looking at that same website that has the jet streams, and looking at that and kind of figuring out, well, it looks like it's going to show up somewhere around North Africa, Algeria, Tunisia, something like that. And but it was all kind of by guess and by golly, of looking at, you can't really tell by that jet stream map exactly what the speed is of the jet stream. They kind of encode that a little bit with color, I think. But so then I thought, well, it'd be much more interesting to look at this model and see if it's complicated. And it's not, it turns out. So this website, essentially, if you have a known starting point, which you have, like for instance, that last position report we got off of the west coast of Ireland, you can take that latitude and longitude, type that into this tool, and put in the altitude of the balloon. It wants that in meters, but that's no big deal to convert from feet to meters, and the starting time. And then there are a bunch of selections in terms of how many points you want to plot, how you want the output presented, because it can present just a simple GIF, it can present a PDF, but what I was more interested in is a KML file that you can then open up in Google Earth. So I can share my screen and kind of show you how that looks. Now this is the latest one that I ran, and this plus here is, you know, the last position that we got today, which is down in southeast of South Dakota, just before crossing over into Minnesota. And this shows basically a 1 week prediction for the positions. And so you can see that, you know, how it's going to track up through Quebec and then Newfoundland and then cross the Atlantic and eventually go into, currently it's predicting it'll go through Morocco, Algeria, and then on up, this would be Libya, and then up into Turkey, and then cross over through, looks like Georgia and Azerbaijan and Caspian, and the prediction ends over here after it goes through like Turkmenistan and Kyrgyzstan. Right at the Chinese border here is where it ends 7 days from now. The neat thing is once you put in the information into this model, you can regenerate. You don't have to keep, you know, you don't have to keep entering this information. You can just click on, and we'll do one of these after I show you the way it looks. But you can just change the new forecast pull down. There's a you know that the trajectory that it predicts is based upon winds aloft data that NOAA is determining somehow. And so so if you run an updated model, it may change the track some, and you know, obviously then the jet stream speeds are going to affect, you know, the whole path. So when you generate this and output a KML file, it ends up, see if I can get this to come up. Yeah, let's hide this. Google Earth here. So this is showing the same model in Google Earth. What's neat is you can use this up in the top left corner in Google Earth is a history slider. And so you can use this history slider, and you'll note that down here where it shows the track, the very beginning of the track, there are dots for every hour. So it shows the date and time in UTC and for each of the dots. And those dots, as you move the slider, will show you where the, you can see where the balloon is going. And then you see daylight as it comes up. So if you're running, it's best to use Google Earth Pro, which is, as I recall, I didn't pay anything for it. It was just a different download. I don't know if they've started. I downloaded Google Earth Pro a long time ago, but they do recommend on the NOAA site that it's best to view get the most out of the KML data by using Pro. And one of the things that Pro has is in the view menu, you can choose to view the sun. So that turns out to be a very handy thing, because then along the track you can see pretty quickly when daylight's going to happen. So if I move this slider just a little bit, if you can read that, Right now, I've got it set where it is 12 o'clock UTC tomorrow, which is actually, if you subtract 7 hours our local time, that would be 5 a.m. So at 5 a.m. tomorrow, the sun will just be coming up over Quebec. And if I move the slider a little more to the next hour, if I can move it that small, next couple hours there, you can see it 1300, which would be 6 a.m., starting to get pretty light. So as you do that, you can see where all the opportunities are for the balloon to start signaling. One of the things that I think, and I've noticed this, is that after sunup, like you said, I'm not necessarily convinced that it's the orientation. I mean, I think that's certainly a part of it. The sun is really low when the sun's coming up, but um, when that little circuit board first gets power, and if you've ever taken your cell phone, gone on a flight somewhere, and you get out and you turn your GPS back on, you may see that it takes a while to get a new lock. And that's because the GPS saves the last set of satellites sort of persistently and tries to go by that, but you're nowhere near that anymore. Whenever his transceiver wakes up, his transceiver board, he's not going to beacon until he absolutely knows where he is. And for one of the reasons is he has to choose the correct frequency from where he is in the world. He wants to make sure he doesn't transmit, if he's over North Korea or Yemen or the UK, is apparently illegal to transmit from a balloon, APRS signals. So he has a bunch of, fenced off areas, if you will. And a couple other hams provided an algorithm for polygons for basically breaking up the world into these polygons that you can detect once he gets a lock where he is, what frequency to use. So when that GPS receiver only comes on for a burst, every 2 minutes or so, it might take an hour before it finally is confident that it knows exactly where it is now and knows what frequency to transmit on. So it seems like you start getting pings, beacons out of the thing about an hour to an hour and a half after sunrise. So for instance, for tomorrow, I would say, and the other thing I do is I'll just Google. So this is Quebec. I think what I did was I looked up, down here is Saguenay. I just Google Saguenay time, and at timeanddate.com, it'll tell you, number one, what's the difference between their local time and UTC, and also when is sunrise. And from that, you can kind of get a better feel than just sort of this sunlight thing here that happens, if you have that turned on in Google. So around 1300, you see is the kind of the first opportunity. Then on just regular aprs.fi, you can go to that area and just see where there are digipeaters, and they're few and far between. I've got marked here VE2RRU-3. This is a booming little guy, and he's kind of out there all by himself. But this track, if I use the measuring tool, is about 80 miles from that repeater. And this, at 40,000 feet, even though that thing's only 20 milliwatts, it regularly gets can get a signal into a repeater that's 200 miles away. So tomorrow morning at around, again, 6 a.m. our time, somewhere 6 to 7 a.m., I would expect that we'll start seeing a beacon up here in Quebec. And it's not going to last for very long, probably, if we move the slider a bit more here and fill in some of these other times. Going out over Newfoundland, but you can see that it starts getting dark then, especially at these higher latitudes. And so really beyond Newfoundland here, there's no more opportunities for a while. So the best we're going to see tomorrow out of the balloon is this area here from about 1300 UTC to maybe 1600 UTC. There's really nothing out here on APRS out farther out. So that's kind of the, we can go out here farther and see where it goes and drag the slider on out like this, and you can see sunlight is going to happen. Let's see, did I overshoot? I haven't really looked to see when sunlight's going to happen here, but if I back this up just a tiny bit, yeah, it's too much. It's real sensitive, the slider. I'm trying to figure out how to get better control over it. But by then, I would update the models and we'll get a better idea. But so at least for tomorrow, that's what it's looking like. Tomorrow morning, it's looking like the opportunities are here. And mostly with this VE2 RRU repeater, there are a couple down here below it that it could possibly hit also, maybe a half an hour or so earlier. We'll have to see. To generate this file is what I wanted to show next, because it's pretty easy. Just go to the website here, and it's called let's see, it's ready.art.noaa.gov. I can post the URL in the chat window here in a second if anybody wants to play with this. But to generate a new one, we can just let me fix this. I think we're zoomed. Yeah, I don't want to go that much. Return to main menu and keep user inputs. So if I do that, let's see. So we want to compute forecast trajectories. All right. And so we go into here and we just do a next at this point. And in the notes that were in that presentation, it says to always use this GFS 192 hour one. So it always seems to be, it starts off with this one here. You go down to this GFS 192 hour one. And then down here is where you put in your latitude and longitude. And it wants it in, degrees and decimal parts of degrees, but actually you can also do degrees, minutes, and seconds. Degrees, minutes, and seconds. So you can do it either way from this screen. You just have to click which one you're using. One of the things that I did was, as you'll see in the next step here, it wants to know the time of this position, but it only gives it to you, on the hour boundary. You can only enter the hour. You can't say it's at, 15:35. So in the case of this current model, the time that this latitude and longitude is actually the last known position. But it was, and it occurred at about 20 minutes before the hour. So to improve on that, I just kind of did a measuring line in aprs.fi to go out 30 miles more along that track, because the balloon is doing 90 miles an hour, and 20 minutes, I'd want to know, well, where would it have been if it stopped transmitting 20 minutes later? Well, 20 minutes is 1/3 of an hour, 1/3 of 90 miles an hour, 30 miles. So I drew a line 30 miles out on Google Earth, and I got the latitude and longitude for that. So I'm going to go ahead and put that in, because that way the predictions aren't off by 20 minutes. So that one is 437705. And longitude is 963061. And so I'm going to go with that, and we'll run a new model. So the next page here, this is where this is where you choose the latest. And you can see the last model I ran was at 12 UTC for today. There's a new model out for 1800 UTC. So we're going to go with that latest model. And then next. And then all of this stuff can pretty much, well, this is where you put the time of that fix. So the time of the fix is, October 20th. And this was the compromise I had to make when I ran it the last time. I had to say it was 2200 UTC, and it was actually 2140 UTC at that last position. So I've corrected that, as I showed you in the previous step, by just kind of moving 30 miles. And now that's really accurately 2200 hours. And total run time is 180 hours. So that's a little over 7 days. 7 days would be what, 168 hours. And so here are your latitudes and longitudes. The height is already correct at 11,973 meters. You do need to, when you put in the height of that last position, you convert it to meters. You want to click this button here that says meters AMSL. That's meters above mean sea level, as opposed to meters above ground level. So the GPS is always giving you, altitude in, above mean sea level. And then I click on the Google Earth button here for what I want for output. And the only other thing I change is that normally this is set for 6 hours for a label interview, and I like the 1 hour label intervals, which will show up on the track as I was showing you, every hour interval. Another nice thing is you can have additional meteorological data along the trajectory. So I say yes, and like they were saying, interesting to put in rainfall. Well, rainfall is not really too pertinent for a 40,000 foot balloon like it would be for a miler balloon that's maybe 24,000 feet. But instead, this one down here is the downward solar radiation flux. That's watts per square meter. So to me, that's kind of a more interesting one for a balloon at 40,000. At that point, you just click the request trajectory once, and it brings up a new screen, and it's now computing it. And you just wait here for a second, and it will complete. And it typically takes probably about done now. Okay, so there's the latest updated track. The track itself, there's a slider bar here. So you can actually move this slider bar. In fact, let's zoom this back in again like we did before. Oops, a bit too much. Actually, not too bad. So you can see that the starting time here is 10:21 at 0 Zulu. You can move this slider along, and the time changes down here on the bottom, and you see the position at that time. So this, even without Google Earth, you could see when it's going to reach the coast of Africa. You just keep moving it here. Yeah, so it looks like around the 25th at 1600 Zulu, subtract 7, that would be 9 a.m. on the 25th is when it's going to get to Africa. Now, off the coast of Africa here, you have the Azores. I haven't checked to see if the Azores have APRS. It would be worth doing that. And also we have to see whether it's daytime. At what point does the sun come up along this track as we're getting to some APRS opportunities. So that's kind of that piece of it. And then you just click on this .kmz to generate the file for Google Earth. So if I click that, it downloads it. It's now in my downloads. I can go back to Google Earth. And I can do a file open and bring in this latest one, which make sure I choose the latest one here. Yeah, 10:20 at 8:06 p.m. So I want to open this one in Google Earth. And you can see the track changed a little bit. And you can also see how I, back it out here, how I moved the track about 30 miles as a starting point. So this is the new track here. Not a lot of difference. It looks like, and this is the first I've seen this, so yeah, it looks like it's going to be pretty consistent with the previous track. And you can probably, I can go in here and just get rid of the previous one so it's not displaying. They should be labeled here, which one is which. Well, I'll just try one and then the other. Let's try this one. That was probably the wrong one. Come back here and see which one went away. I'll turn on the other one for a second. Oh, that was the right one. Okay. So now we can redo the slider deal here. Kind of move this slider along. And I haven't completely figured out how the slider works. It has two sliders. And so I usually go to the end and then I take the little, there's one that you can disconnect from it if I can get close enough to it. Click the right one here. There we go. Drag that all the way to the left, drag the other one all the way to the right, drag this one back to the left till I get them completely spread apart like that. And now it should work. So again, I just bring it back to where we are today. And where are my labels? I probably have to click on something to get the labels. Well, I seem to have something screwed up here because the labels aren't popping up.
There's some labels there.
Oh, yeah, they're way over there. Now what happens when I'm doing this? Okay, they're getting populated, but they don't, it looks like my slider isn't set far enough. It's not, I'm gonna have to look into that. Oh, there we go. Now they're showing up. All right, so it looks like everything is going to be about the same in the morning. 1300, which is 6 a.m. It's still going to be coming to almost in a beam position from this this repeater
Where do you think it is right now, Keith?
Yeah, well, let's see. What time is it right now? It is, let's see, 8 p.m. That's 20, and add, it's 7 hours later in UTC, so that's 3 a.m. UTC. So if we come down here,
12.
So it's right here, about to get into the Great Lakes, crossover into Lake Michigan. So coming up on Green Bay. So that's, did I do that right? 8 p.m. is yeah, 2000 UTC, add 7, that's 27, subtract 24, so 3 a.m. So, yeah. So that's basically kind of what I've been doing. It's just a combination of using generating the track from the latest data and then figuring out along that track at what point the satellite's going to see daylight, and then along that daylight segment on the aprs.fi map, look at that area and see if within 200 miles are there APRS digipeaters that, could pick up the signal. So that's kind of the idea.
Well, that's pretty cool. There's one thing that I noticed, and I brought this up when Trevor was with us last week, that I observed when the balloon was just crossing the U.S. So there were plenty of eye gates, plenty of stations that should be able to copy it and dump it onto the APRS network. We saw it wake up, come online, and send out a packet, and then it was about 20 minutes before we saw the next packet. Yet it's programmed rather to beacon every 2 minutes. The board has a capacitor on it, and so if it's beaconing every 2 minutes, when it's not transmitting, those solar panels are charging the capacitor and trying to bring it up to a voltage. I think the at Mega chip this is one running. I believe it's running at 3.3 volts. You can run them at less. I think they need around 3.6, 3.8 volts on board for this thing to work. And so my hunch was that when it came on, it used up all the charge it had at that moment. And then it took 20 minutes to get it back up again to where there was enough, where the voltage was high enough that it could transmit again. And then as the sun gets higher, then the capacitor and the solar panels are easy, can keep up with it. That's a hunch I had. I don't know if it's sound or right or anything. And then when I mentioned that, that's when Trevor said about the orientation of those solar panels are flopping around there, and they got to swing around and face the right direction, which isn't always going to be right when the sun is low on the horizon.
Yeah,
so
that's true.
It's a combination of all kinds of things.
Yeah. One of the other interpretations, because I saw that same thing this morning, when it first beaconed here in Montana, and then 2 minutes later it beaconed again right here, and then it went dead for quite a while. But I was looking at if we looked at that time at the APRS traffic, this is I-94, I-90, I-94. At that particular time, when it was transiting this area in here where it wasn't transmit or wasn't apparently getting a signal out, it was competing with, there were cars, you would not believe all of the APRS traffic going to these local repeaters here. And this little 20 milliwatt guy is trying to get a signal in with all these moving vehicles that are,
yeah. So it's competing with the morning commute.
Yes, exactly. And then once it got clear of that area, right around here, it started doing every 2 minutes, and it was hitting a repeater over to the east that was out in the middle, kind of didn't have any traffic. So it was nice and quiet. It's 20 milliwatt packets going out, and there's nothing that it's competing with, and it just starts getting those through okay. So, but you're right, at that that really low angle of the sun, I wonder really how much those panels are actually flopping around, because yeah, it's in 100-mile-an-hour jet stream, but it's like, you've sailed. If you point your sailboat directly downwind, there's like no wind at all
You don't feel
because
it.
you're moving with the wind. It can get pretty hot on board when you're going directly downwind, especially if it's constant. And these jet streams are really, really constant at 40,000 feet. So as far as the balloon's concerned, it's in still air. You know, it's not like it's got a breeze that is, you know, dragging the panels behind it or something like that. The whole thing is moving along at 100 miles an hour. And if there's wind shear, of course, along at 40,000 feet, yeah, that could definitely cause the whole thing to be swinging around. But again, 40,000 feet, I don't typically think you get a lot of that either. It's a great advantage. And I have to say, two things have really impressed me about this. Number one, Trevor McDuff did an awesome job of pre-weighing and filling with probably the good stuff, the not the party store helium that's like 20% nitrogen, but the good stuff, which allows you to really calculate then how much of an initial weight that you want to put onto the balloon and fill the balloon to neutral buoyancy, because that's going to determine how close you can hit a stable 40,000 feet, where it'll be neutrally buoyant with the less weight of its actual payload. And he nailed it. I mean, that balloon is ranges from, worst case I've seen is around 39,200. I've seen it up a little bit above 40,000, you know, earlier on. I don't know what the failure mode is for that particular kind of, you know, that $170 balloon that he's using. Do they just eventually, do they fail suddenly? Do they just slowly have some permeability and start losing some buoyancy? So far, it's staying above 39,000 feet, so that's really good news. But I don't know if they, you know, if they just get rigid and pop or what happens. But so far, so good. He did a really good job of getting that balloon up and stabilize at 40,000 feet. The other thing that impressed me is this NOAA software. I mean, when I saw, first of all, when it was in Ukraine, when last signal we got was in eastern Ukraine, and I started using this tracking software, and you know, it basically appeared that we were going to be, when it crossed over into Russia, and there were no digipeaters. Plus, it got dark, so by the time it got farther north in Russia, there's nothing there during the daylight. So we didn't have it for a couple of days, but the model said that after it crossed through Russia and through outer Mongolia, then it crossed over into China, inner Mongolia, and was going to hit Beijing right around sunrise. And Beijing, that whole area from all around Beijing, is lots of digipeaters. And it looked like Beijing would be right at sunrise, so I didn't really expect anything from Beijing, but probably more from just to the east of there at the coast of the Yellow Sea is Tianjin. And so it looked like, well, that's where we're going to pick it up. And because the sun will have been up for an hour and a half or something like that. And it woke up right there. Actually, their model was off by about 100 miles. So it actually came across the Yellow Sea coast 100 miles south of where the model said. But remember, that 100 miles south is after it's crossed, what, a 4,000 mile snaky path from Ukraine clear to, clear to Beijing and beyond Beijing. The other interesting outage was when an earlier model showed it crossing Pyongyang, you know, the capital of North Korea. So I expected, okay, well, the satellite's going to, the transceiver is going to go off the air, you know, out of respect for that. But then later model showed it was actually going to cross the northern part of South Korea, but it still went out. And I did a little more research, and that fencing algorithm they use is based upon kind of drawing polygon around the areas. And, I'm sure when they drew that polygon, they gave North Korea a bit more of a berth than, they didn't just draw the polygonal line segment right along the border. So it was in an awkward area where I think it just went dark because it was too close to the North Korean border. And then it got out into the Sea of Japan, and it was getting late in the day, but it still started getting good pings off of the coast of Japan, off a repeater there before it got completely dark. But again, then the model from the Sea of Japan to this morning in Montana, I could see, well, nothing's going to happen because the model took it arcing along south of the Aleutians, and on aprs.fi, the only thing up in there is up in Anchorage, and that was about 480 miles north of the path. But the Aleutians were about 200 miles away, but there just wasn't anything on there. So that was a day of travel where it, I'm sure it was beaconing, but there was no one there to hear it. But then sure enough, it showed up across the border into Montana, just like the model said it was. So there's got to be some serious atmospheric physics built into that simple little model that we just ran to get that right. Very impressive. So that's it.
Well, that is great, Keith, and this is very interesting. And why don't we go ahead and turn your screen off so we can all see the grid again, and maybe there's some other people that would like to do do comments.
Yeah, let's see. Where do I do that?
I can do it for you if you want.
Yeah, go ahead and do it for me because I'm having trouble
go.
finding my. Oh, there it is. There it is. Thank you.
Yeah, well, we still got 12 people here, so we got some people that are interested. Anybody want to comment on what a fabulous presentation, Keith?
Oh, thank you. Well, it's just been. I was just. The more I saw that this number one, that this NOAA thing was predicting so nicely, and that the balloon was staying at 40,000 feet, I was just like, this is pretty cool for a little tiny, such a wonderful engineering and firmware that the gentleman in, I forget his call, but he's ex-NASA guy down in Huntsville who builds these little APRS transceivers with firmware that has all the geofencing algorithms in there. He's got to be limited by memory on how many of these points for each polygon, so that he knows what frequency to be on because this balloon could go anywhere on Earth. So he's got to be on the right frequency. And
it was kind of interesting this morning when I came in and checked my map, and I went, holy cow, it's in Montana. And I stepped out into the hallway. My wife was going by, and I said, hey, the balloon is already gone around and is now over Montana. And even she exhibited an element of excitement about it, which is rare when I'm talking about anything that has to do with amateur radio.
Yeah.
So,
well, and I think Trevor's students, his elementary students, are probably pretty stoked.
Oh gosh, they got to be pumped. They're walking around 2 feet off the ground.
Yeah, and because they were all part of that launch, and it's gone all the way around the world, and it looks like it's gonna maybe make it's still going good. So
yeah, it's looking good. Yeah.
Has there been any countries that have tried to shoot them down?
I don't know. It'd be. I doubt this thing shows up on radar. Now it does give off a radio signal, so that would be helpful. But I mean, there's really. I don't think it has. It's not Mylar, so I don't think it has any radar reflectivity. It's a clear, very thin polyethylene.
Yeah, Trevor responded to that same comment last week about how impossible it would be to try to hit something that small at 40,000 feet. Yeah, it's just you see it, and it's you see them hold it in their hand. The balloon isn't anything that anybody's going to be able to detect because it's just thin mylar or whatever.
How about commercial airlines? Would they be running into them maybe?
Well, they discussed that too, and the comment was that it would probably, if a plane was to, well, first of all, if the plane hit it, it would be pretty much insignificant.
Right.
My concern would be if it got sucked into a jet engine, and it probably would have been, shredded. I think we'd be more likely to clog up a garbage disposal in the kitchen sink than do anything to a jet engine with something that size. But who knows?
Yeah. Number one, it's such lightweight, such thin polyethylene that it would probably not even affect one of those big turbines. Might put just such a light smear that I don't think it'd even debalance the turbines or anything. The other thing is at 40,000 feet, commercial airliners they generally peak out around 37, 38,000. Now Learjet, business jets, they like those altitudes up above 40,000. But it's a big sky out there, and the chances of hitting that balloon are really, really small. Birds are another matter. Bird strikes are a real problem for pilots. Typically, takeoffs and landings is where bird strikes occur more with aircraft, and a bird has some significant weight. This whole balloon thing, I forget what it weighs, but it's like nothing. It's like 12.
It's like
grams.
11 or 12 grams.
Yeah, it's like 12 grams. So there's just no weight to it. So I think that it's really pretty safe.
Hey, Keith, got a question about altitude. Do you know if this thing is using, how is it measuring its altitude? Is it a barometric altimeter?
GPS.
Okay,
GPS
so
gives you altitude and position and speed.
Right.
So
My-
all
my
that
under-
comes out of it.
My understanding that airliners don't actually use a real altitude. They use something called a standard altitude.
Yeah.
And I believe that means, I mean, I was actually on an airplane one time with my GPS, and the pilot came on and said, we're flying at 39, and I couldn't hold myself in. I said, you liar. Turns out the guy next to me was an executive at the airline. He said, well, let me explain to you about standard altitude.
Yeah.
Once you go through 18,000 feet, we no longer measure actual altitude because all the airplanes in those days, it wasn't that precise. So everyone sets their altitude.
Well, not only that, it's that you've got planes coming from all different areas where the atmospheric pressure is different. So you set your altimeter to 29.92
Right.
When you're up above a certain altitude, and that gives you the standard altitude.
Right. So that could be 1,000 feet off from what a GPS would give you.
But Chris, I'm surprised the guy didn't tell you to shut that darn thing off. They allow you.
This was a long time ago before they got uppity and snarly.
Oh, okay.
Yeah.
All right.
This is in the old days when people actually gave a shit about science.
Yeah.
Now, have you heard of any that go north and south rather than east and west?
No, it's just pretty much the jet stream. The jet stream pretty much is a west to east flow. If you look at a large jet stream map, I think there's, a northern hemisphere flow and a southern hemisphere flow for those. And so if you launch from the northern hemisphere, you're pretty much, going to ride that flow around. It does kind of snake up and down. And as you saw from this next model, it looks like we're going to see the balloon potentially cross over more of mainland Africa, North Africa, but not just skim by along the coast. It looks like it's going to be down into Africa enough to hit a couple of countries, which was something Trevor was hoping for. So I think he's going to get it probably on this particular orbit. And it'll be interesting too, because it's There's probably going to be a lot more signals for it in, by that first pass, it went up above Kazakhstan, which is, you're way up in Russia and just like big wilderness areas that don't have anything. But it looks like this second circuit's going to take it through, Armenia and Azerbaijan and Turkmenistan and all the stands where there's a lot more of this kind of stuff going on. So we'll probably get better signals with it staying in a more southerly latitude.
This is the website that I've been using to look at the jet stream, and it's got a slider on it that I think goes into the future and stuff. And it's certainly a little rougher model than what you've been working with, but it's held out pretty cool. And you can see this is kind of in line with what you're seeing. There is a slider, and I'm not sure if I move this forward to the 26th, where it might be. And so you were thinking it would be over there around the 28th. If we move this over to the 28th, some things are happening maybe in their model there, but I'll put a link here in the chat room if anybody wants to play with this one. It's been helpful to me in guessing what might be going on. Not as accurate as what you've been doing, Steve, or Keith, but it has been useful anyway.
Yeah, I like the ability to just generate the track and then read it into Google Earth, because then you can turn on and off all these different Google Earth features like roads, cities, rivers, whatever. You declutter your map, or you can add a lot more information to kind of help you when you're looking at Google Earth and figure out where is this same spot on aprs.fi. If we actually had GIS software, the ultimate would be combine the KML data layer with the sunlight data layer with the repeater, all of the APRS repeaters in the world, a layer, and then those three layers together with one view would just be at a glance. You could see, okay, daylight happens here. Here's a repeater. That would be the ultimate, to synthesize all of those together instead of switching back and forth between the APRS view and the Google Earth view. And for all I know, it may be possible to generate some kind of KML file with all the APRS repeaters that could also be brought into Google Earth. That would kind of help that along.
You were saying how many hours before it might wake up again? Was it 7 hours or?
I think I said like 6 a.m., 7 a.m.
By the way, I just Googled it just for reference. The 777 has a max altitude of just over 43,000 feet.
Okay. Do you see the map now?
Yeah.
Okay. Yeah. So what I was doing was I was adding hours down here. I started by adding 6 hours and then working through, but I sent the link to it there. So the links are there. They're simple tools that give you a rough idea of what's going on.
Yeah, I'll put this link for the the NOAA little modeling thing, just the web link, and anybody can play with it then. Just need to back this up.
Yeah, that one works.
Oh yeah.
Okay.
Very good.
Okay. All right. Good. Yeah.
All right. Now I can bookmark it. Okay.
Does anybody do you remember, did Trevor ever mention the way in which these $150 balloons fail? I mean, if they're at 40,000 feet and they aren't they're riding along pretty much undisturbed. I assume it's some kind of fatigue, seams that get brittle or something. It is in quite cold air.
I don't remember him mentioning anything about that.
Yeah, I might look into see what, wherever you buy those balloons, see what they say about longevity.
I wonder if it would have anything to do with how much moisture is in. So they're putting helium, I guess, into the balloon, or they could use hydrogen. But there might be also other gases in there, oxygen, and I wonder if in some cases they get some humidity that freezes. I don't know.
They did say that that the helium that you get at the party balloon stores is not pure helium. So
Right.
if you go to like a lab supply, something like that for helium, you're going to get much. I mean, obviously it's not going to be 100% helium, but the amount of other trace gases like nitrogen, which is most of what air is made up of, 70% nitrogen, that sort of stuff is going to be at a minimum. So you're going to be able to, more accurately compute what the altitude is going to be at, because that volume of helium has to displace, the same volume of regular air, but at the density at 40,000 feet. So
I would
Just as a
suggest,
note, he was saying that he did not use the party balloon. He used the commercial.
yeah,
helium.
use the
Yeah.
good stuff, and that's probably well worth the money. If you've already spent $150 on the balloon and you really want to have something exciting for the students, having balloons stay up for multiple orbits, there's nothing better than that.
I would suggest that you need to ask Trevor about the balloon failure modes, because the SBS website is just a marvel of marketing, rah BS.
Oh,
Not useful information.
all right.
Well, I know that Trevor got a grant. Was it a NOAA grant or it's a NASA grant, I believe. And they got the money to purchase. It was either 10 or 12 of these balloons, and they were scattered around the country. If you saw the launch, you saw all these various launches there, and they were all party balloons. That's what they purchased with the grant money. And so he had a party balloon for his students, but he, out of his own pocket, purchased this balloon. What a move. And he was talking about that means he now has a spare party balloon.
Yeah.
But why use a party balloon ever again when you?
Yeah. Oh yeah. Yeah. That's actually an event put on by the Smithsonian National Air and Space Museum. The one that this particular balloon launch is still flying on, and all of the others have failed, I think. But they were all Mylar. So all those Mylar balloons, 24,000 feet, you're in weather. And it doesn't take many droplets of moisture or ice to form on one of those Mylar balloons, and down she comes. And then it just ices up more and more on its way down. And so, yeah.
It was a good one. We really appreciate it, Keith. We're approaching it's time to start stacking chairs and to move out of the room. Anybody have anything for the group before we pull the plug?